To finish off section 3.9, we're going to cover quite a bit of problems involving hyperbolic trig functions and inverse of hyperbolic trig functions. So we're going to start out by defining these. Sin represents hyperbolic sine of x. This is e to the x minus e to the negative x over 2. Hyperbolic cosine is the same thing with a plus. And I'm pretty sure that this didn't get covered in pre-cal. So we're going to write out the 6 hyperbolic trig functions. So hyperbolic tan is the same as hyperbolic sine over hyperbolic cosine. And it will be e to the x minus e to the negative x, all that over e to the x plus e to the negative x. Basically, it's the sine stuff divided by the cosine stuff, and then you let the 1/2s cancel. So hyperbolic cotangent is this stuff flipped. We got hyperbolic secant and hyperbolic cosecant. Hyperbolic secant is the same as 1 over hyperbolic cosine. And hyperbolic cosecant is 1 over hyperbolic sine. Okay, so this is what these hyperbolic functions are in terms of e to the x and e to the negative x. We're going to define the derivatives of all of them next, and then we're going to do a little bit of a couple derivatives involving these, and then we have a whole other block of these to write down. So going to write these down. So the derivative of sine is, or hyperbolic sine is hyperbolic cosine. Derivative of hyperbolic cosine is hyperbolic sine. And we might expect that, like, since derivative of cosine is sine, we might say, well, shouldn't this have a negative? But it doesn't, just the way it's defined. So this is similar, but the signs are off from your regular trig functions. So derivative of hyperbolic tangent is hyperbolic secant squared of x. Derivative of hyperbolic cotangent is negative cosecant squared. Negative hyperbolic cosecant squared of x. So tangent and cotangents, hyperbolic trig functions stay the same. So we'd expect them to be secant and cosecant. Theirs work a little different. So hyperbolic secant's derivative is negative hyperbolic secant of x tangent of x. So its hyperbolic tangent of x. Its sign is different from what you'd expect. And cosecant is also negative. Okay, so here are our 6 hyperbolic trig derivatives. Okay, so let's do a couple examples. Let's say, what's the derivative of hyperbolic secant of x to the fourth. Well, the chain rule is going to apply. Hyperbolic secant is the outer function. X to the fourth is the inner function. So we'll take the derivative of hyperbolic secant by this equation, but instead of x's, we'll have x to the fourths. And then we got to multiply it by the derivative of x to the fourth, which is 4x cubed. Okay. Do a little bit from the book. The book wants us to find, for example, 8, I guess. We got part A. Find d dx of hyperbolic cosine of 3x squared plus 1. And part B, take the derivative of hyperbolic sine times hyperbolic tangent. Okay, so hyperbolic cosine is the outer function of 3x squared plus 1 is the inner function. The derivative of hyperbolic cosine is hyperbolic sine. So we will get hyperbolic sine of the inner part left alone. And then we got to multiply it by the derivative of the inner part, which is going to be 6x. So that'll be our answer to part A. For part B, the product rule is going to apply. So what we'll do there, we will leave the sine alone. We'll take the derivative of hyperbolic tangent, which should be hyperbolic secant squared. Plus, now we take the derivative of hyperbolic sine, which is hyperbolic cosine. And we leave the hyperbolic tangent alone. And I guess some of that stuff we could simplify, but I think we'll just leave it like this. So it's good enough. Okay. Now we got one more group of problems here. This is going to be the inverse of the hyperbolic functions. So we're going to put the derivative of inverse sine. We have the derivative of inverse hyperbolic cosine. Same for hyperbolic tangent. And cotangent and secant and cosecant. So these are the inverse hyperbolic trig functions. Alright, so this will be the equation. Then over here we'll have the domain, which is where this exists. So, or the domain of each of the individual functions. So this will be the equation of the derivative, and this will be the domain of the function. So the equation of the derivative is 1 over square root of x squared plus 1. For cosine, it's 1 over the square root of x squared minus 1. Inverse hyperbolic sine has derivative of all x. Inverse hyperbolic cosine has domain x greater than 1. For hyperbolic tangent and cotangent, they have the same equation but different domains. It's 1 over, oops, got that one backwards, 1 minus x squared. This one's 1 over 1 minus x squared. The part where inverse hyperbolic tangent exists, it's when absolute value of x less than 1. And hyperbolic cotangent is for when absolute value of x is greater than 1. And then for secant and cosecant, we get this stuff. Okay, so these have kind of different forms. This one's for 0 less than or equal to x less than, 0, x is greater than 0 but less than or equal to 1. And the bottom one, x can't equal 0. So for these, what we want to do for this last one is just use what is if y equals hyperbolic cotangent of 3x squared plus x, I want to find y prime. Okay, so we're going to do hyperbolic cotangent, inverse of hyperbolic cotangent equation. To take the derivative, we're going to leave the inner part alone, so the 3x squared plus x will replace the x's. Then we multiply it by the derivative of that. So it's 1 over 1 minus x squared. So this will be 1 over 1 minus the inner part left alone times the derivative of the inner part, which will be that. Now let's do one more. Y equals inverse hyperbolic cosecant of sine of x. So we're going to get inverse hyperbolic cosecant equation with sine of x replacing the x's. So that'll be negative 1 over that. So I'm going to write this equation down with blanks where the x's used to be. And then we're going to put the sine of x, which is the inner part left alone. So we're going to put the sine of x in the blanks. And then we got to multiply this by the derivative of sine, which is cosine. And that'll be our equation. And that basically wraps our section up.